तो बच्चों हम लोगों ने मेज़रमेंट, यूनिट एंड डायमेंशन की बात की और एरर पढ़ाया आपको। अब हम लोग आज मैकेनिक्स का एक इम्पॉर्टेंट टॉपिक है वेक्टर। तो आज हम लोग वेक्टर को डिस्कस करेंगे। वेक्टर बहुत इम्पॉर्टेंट है इसलिए कि वेक्टर का यूज़ स्टार्टिंग फ्रॉम मैकेनिक्स टू मॉडर्न एंड थर्मोडायनेमिक्स हर जगह, ईच एंड एवरी जितने भी टॉपिक्स हैं आपके फिज़िक्स के, वेक्टर के बगैर आप नहीं समझ सकते हैं। ख़ास करके मैग्नेटिक इफेक्ट ऑफ करंट वगैरह में वेक्टर का बहुत ज़्यादा यूज़ है। तो अगर सही पूछिए तो मैकेनिक्स समझने के लिए आपको वेक्टर है, मैथमेटिक्स यूनिट, मैथमेटिक्स में आप कर सकते हैं डिफरेंशिएशन, इंटीग्रेशन एंड फ्री बॉडी डायग्राम एंड कुछ कंजर्वेशन प्रिंसिपल। उसके बाद हम लोग मैकेनिक्स को बहुत आसानी से समझ लेते हैं। तो वेक्टर को फिज़िक्स के हर टॉपिक को समझने के लिए बहुत ज़रूरी है। इवन मैथमेटिक्स में भी आपके वेक्टर का इम्पॉर्टेंट रोल है। तो हम लोग स्टार्ट करते हैं वेक्टर। तो फिज़िक्स में जितने भी फिज़िकल क्वांटिटीज़ हैं, तो जितने भी फिज़िकल क्वांटिटीज़ हैं उनको हम क्लासिफाई करते हैं दो पार्ट में, स्केलर एंड वेक्टर। स्केलर एंड वेक्टर एंड वेक्टर। तो ये जो फिजिकल क्वांटिटीज आपके हैं जिनको हम लोग क्लासिफाई करते हैं स्केलर एंड वेक्टर। फॉर एग्जांपल स्पीड है, डिस्प्लेसमेंट है, डिस्टेंस है, वेलोसिटी है, एक्सेलरेशन है, फोर्स है, वर्क है, पावर है, एनर्जी है, मैग्नेटिक इंडक्शन वेक्टर है, इलेक्ट्रिक फील्ड इंटेंसिटी है, मैग्नेटाइजेशन वेक्टर है। They all can be classified either as a scalar or as a vector. अब एक और क्वांटिटी है जिसको टेंसर हम लोग कहते हैं। तो चूँकि +2 लेवल पे टेंसर का कोई कॉन्सेप्ट नहीं है, अभी तक कोई क्वेश्चन टेंसर से नहीं पूछा गया है, तो हम लोग टेंसर को बेवजह डिस्कस नहीं करेंगे। तो वी आर कॉन्फाइंड ओनली टू स्केलर एंड वेक्टर। तो हम लोग डिफाइन करते हैं स्केलर को कि स्केलर्स आर दोज क्वांटिटीज which has only magnitude, those quantities which has only magnitude and no direction, which has only magnitude, which has only magnitude and no direction, only magnitude and no direction। तो स्केलर के पास सिर्फ मैग्नीट्यूड है, कोई डायरेक्शन नहीं है। डिस्टेंस ऑफ 5 मीटर, राइज ऑफ 5 kg, 10 सेकेंड। तो 10 सेकेंड, 20 सेकेंड, 5 kg, अ डिस्टेंस ऑफ 5 मीटर, या और भी वर्क में 10 जूल। तो ये सारी चीज़ें स्केलर हैं। वेक्टर के साथ खूबी क्या है कि वेक्टर को हम लोग डिफाइन करते हैं those quantities which has both magnitude and direction and follows vector laws of addition and follows vector laws of addition। तो ये वेक्टर लॉज ऑफ एडिशन क्या है हम लोग देखेंगे। तो हम लोगों ने डिफाइन किया कि स्केलर्स वो क्वांटिटीज़ हैं जिनके पास सिर्फ मैग्नीट्यूड है, कोई डायरेक्शन नहीं। वेक्टर के पास मैग्नीट्यूड भी है, डायरेक्शन भी है और ये वेक्टर लॉज ऑफ एडिशन को फॉलो करता है। सो वेक्टर्स हैव बोथ मैग्नीट्यूड एज वेल एज डायरेक्शन एंड फॉलोज वेक्टर लॉज ऑफ एडिशन। तो ये आपके वेक्टर का मामला हुआ। स्केलर में डिस्टेंस है, स्पीड है, वर्क है, करंट है, टाइम है, ये स्केलर क्वांटिटी है। डिस्प्लेसमेंट, वेलोसिटी, एक्सेलरेशन, फोर्स एटसेट्रा ये वेक्टर क्वांटिटी है। अब हमको आज पहले दिन से ये याद नहीं करना है कि विच वन इज़ अ स्केलर क्वांटिटी एंड विच वन इज़ अ वेक्टर क्वांटिटी। टाइम के साथ आपको धीरे धीरे क्लियर हो जाएगा कि कौन सी फिजिकल क्वांटिटी स्केलर है और कौन सी फिजिकल क्वांटिटी वेक्टर है। नाउ अ वेक्टर इज रिप्रेजेंटेड बाय अ स्ट्रेट लाइन विथ एरो ऑन इट्स टिप। अ वेक्टर इज represented by a straight line with arrow on its tip. Length of the line है, ये मैग्नीट्यूड को बताता है, सेंस ऑफ एरो डायरेक्शन को। तो लेंथ लाइन का जो है लेंथ शो करेगा मैग्नीट्यूड को। वेक्टर का मैग्नीट्यूड लेंथ से रिप्रेजेंटेड है। सेंस ऑफ एरो ये डायरेक्शन को बताता है। तो वेक्टर इज रिप्रेजेंटेड बाय ए स्ट्रेट लाइन विथ एरो ऑन इट्स टिप। ये देखिए इसको ब्लैक बोर्ड पे मैंने डायरेक्शन निकालने के लिए दिखा दिया। दिस इज योर नॉर्थ, दिस इज योर साउथ, दिस इज योर ईस्ट एंड दिस इज योर वेस्ट। ये अप है और ये डाउन है। देखिए अगर आप इस ब्लैक बोर्ड को आप तोड़ के हॉरिजॉन्टल कर दीजिए लाइक दैट, तो अगर ऐसे आप कर देंगे ये, तो दिस इज नॉर्थ, दिस इज साउथ, दिस इज ईस्ट एंड दिस इज वेस्ट एंड दिस इज अप। तो एरो अगर निकलता है सो द टिप ऑफ द एरो लुक्स लाइक दैट एंड एरो का टेल ऐसा होता है अप एंड टेल। तो दिस इज योर डाउनवर्ड वेक्टर, दिस इज अप। यानी अगर आप ब्लैक बोर्ड को ऐसे कर दिए तो साउथ टू नॉर्थ, ईस्ट वेस्ट, अप एंड डाउन। तो ये आपका मामला हुआ। सपोज आपको किसी ने कहा कि राइट अ वेक्टर ऑफ 5 यूनिट टूवर्ड्स ईस्ट, राइट अ वेक्टर ऑफ 5 यूनिट टूवर्ड्स ईस्ट। आपको कहा गया राइट अ वेक्टर ऑफ 5 यूनिट टूवर्ड्स ईस्ट। तो हम लोग कुछ नहीं करेंगे, एक 5 सेंटीमीटर के लेंथ का लाइन लेंगे एंड एरो को ईस्ट की तरफ कर देंगे। 1 सेंटीमीटर इज इक्वल टू 1 यूनिट। So 5 centimeter is 5 unit. So this is a vector of 5 unit towards east. This is a vector of 5 unit towards west. This is a vector of 5 unit towards west. Vector of 5 unit towards west. Vector of 5 unit towards west, and this is a vector of 5 unit towards north, and this is a vector of 5 unit towards south. तो इस तरीके से हम लोग a vector of 5 unit towards east, a vector of 5 unit towards, this is towards east, vector of 5 unit towards west, vector of 5 unit towards north, vector of 5 unit towards south. Now this is a vector of 5 unit 60 degree north of east. this is a vector of 5 unit 60 degree north of east. A vector of 5 units 60 degree north of east, and again it is a vector of 5 unit 30 degree east of north. इसको ऐसे भी लिख सकते हैं, vector of 5 unit 30 degree north 30 degree east of north. तो 60 डिग्री नॉर्थ ऑफ ईस्ट, ऑफ का मतलब यहाँ हिंदी में से होगा, सो 60 डिग्री नॉर्थ ऑफ ईस्ट या 30 डिग्री ईस्ट ऑफ नॉर्थ, या ऑफ का मतलब से है, स्टार्टिंग फ्रॉम ईस्ट टूवर्ड्स नॉर्थ एट एन एंगल ऑफ 60 डिग्री. नाउ again this is a vector of 5 unit 60 degree west of north, 60 degree west of north, or 30 degree north of west, 30 degree north of west. तो इस तरीके से हम लोग लिख सकते हैं. नाउ दिस इज अ वेक्टर ऑफ 53 डिग्री साउथ ऑफ ईस्ट, अ वेक्टर ऑफ 5 यूनिट. दिस इज 53 डिग्री साउथ ऑफ ईस्ट. तो इस तरीके से हम लोगों ने वेक्टर को लिख दिया, वेक्टर ऑफ 5 यूनिट. नाउ so you can write geometrically any vector whether towards east or towards west or towards north or towards south or towards 60 degree north of east or 60 degree north of west, etc. Now this is a vector of 5 unit 45 degree north of east or 45 degree east of north. It is equally inclined to both north and east. It is 45 degree east of north, a vector of 5 unit 45 degree north of east or 45 degree east of north. 45 degree east of north or 45 degree north of east, and it can be written as a vector of 5 unit northeast. In the similar fashion, this is a vector of 5 unit northwest. This is a vector of 5 unit southwest, and this is a vector of 5 unit southeast. So this is a vector of 5 units southeast, this is a vector of 5 unit northwest, vector of 5 unit southwest, and vector of 5 unit northeast. So now geometrically we can write any vector, northeast, northwest, southeast, etc., this and that. So now mathematically a vector can be represented by taking a coordinate system. The observer will be situated at the origin of the coordinate system. Origin of the coordinate system. For example, suppose we want to locate the position of this point. Locate the position of this point. Now we will take this origin. This is the x-axis, this is the y-axis, and this is the z-axis. Now to locate this point, this is x-axis, this is y-axis, and this is z. We will draw a perpendicular on the xy plane, x and y. That plane which contains x and y is called xy plane. So this is the xy plane. X and this is y, xy plane. This is x and this is y. This is of course the point P. We draw a perpendicular from that point in the xy plane, and the length of the perpendicular is say 12 meter or 12 unit. The length of the perpendicular is say 12 unit. Now this is the length of the perpendicular. The length of the perpendicular is of course in the xy plane. We of course showing the xy plane like that. So the length of the perpendicular is, if the blackboard is like that, this is the length of the perpendicular. Length of the perpendicular. Now draw the perpendicular from point P dash to the x-axis and of course to the y-axis. This perpendicular is your 3 unit or 3 meter say, and this is the 4 meter, and this is from P to P dash, it is 12 meter. So if you want to catch this point P, you will have to move 3 meter in x-axis, 4 meter in y-axis, and 12 meter in z-axis. If you of course break the blackboard and the blackboard is like that, this is x, this is y, and this is z. So to catch this particle or the point, 3 meter in x-axis, 4 meter in y-axis, and 12 meter in say z-axis. Now this 3 meter and 4 meter is 5 meter. Pythagoras theorem. 3 square plus 4 square is 5 square, and this is your 12. So this OP dashed, this is your 3, this is your 4, this is 5, and this is 12. So this is 5 square plus 12 square, and you can write OP is equal to OP dash square plus 12 square. And what is OP dash? OP dash is 3 square plus 4 square plus 12 square. So OP square, P is of course a point in the 3-dimensional space, and we can easily write of course OP as 3 square, 4 square, or 12 square. So any vector A can be written as A is equal to AXI plus AYJ plus AZK. AXY and AZ are the X, Y and Z component. This is the X component, this is the Y component, and this is the Z component, and this is your OP. X, Y and Z. So X, Y and Z अब अगर हम लोग इसको लिखना चाहते हैं इस वेक्टर को, तो मैंने आपको ये कहा इनिशियली, इसको ये लिख सकते हैं आपके जब आपने इस P को लिखा तो दिस इज योर 3 मीटर इन x एक्सिस, 4 मीटर इन y एक्सिस एंड 12 मीटर इन z एक्सिस। तो OP इज 3 मीटर इन x एक्सिस, 4 मीटर इन y एक्सिस प्लस 12 मीटर इन z एक्सिस। So you can of course locate OP 3 meter in x axis, 4 meter in y axis and 12 meter in z axis. So this is your OP. This is the origin. This is x axis, this is y axis, x, y and this is your z. 3 meter in x, 4 meter in y and 12 meter in z. अब ये काफी लंबा हो गया आपको लिखने में. So we define a term called unit vector. Unit vector I, unit vector in x axis, J, unit vector in y axis, K, यूनिट वेक्टर इन z एक्सिस। अब जो यूनिट वेक्टर के जो कैरेक्टर हैं वो ये है कि इसका मैग्नीट्यूड 1 होता है। द मैग्नीट्यूड ऑफ यूनिट वेक्टर इज 1। सो दिस इज योर मॉड 1। मैग्नीट्यूड ऑफ यूनिट वेक्टर j इज ऑल्सो 1 एंड मैग्नीट्यूड ऑफ यूनिट वेक्टर k इज ऑल्सो 1। नाउ this is 3 meter in x axis. If you attach I with 3, this is a vector of 3 unit towards x axis. If you attach j with 4, this is a vector of 4 unit towards y axis. And if you attach 12 with k, this is a vector of 12 unit in the z axis. So unit vector when attached to any number made is of course a vector. इसको एक vector बना देता है. I attached to 3 make it a vector of course in the x axis, a vector in y axis and vector in of course z axis. So now 3 meter in x axis, 4 meter in y axis and 12 meter in z axis, vector OP can be written as 3i plus 4j plus 12k, and the length of the vector OP, length of the vector that is magnitude or magnitude of the vector can be written as OP mod is coefficient of I square, coefficient of j square and coefficient of k square, and this is 9 plus 16 plus 144, that is OP is 169 root under that is 13. So any vector A can be written as A is equal to AXI plus AYJ plus AZK, where AX, AY and AZ are the X, Y and Z component of the vector A, and the magnitude of vector A can be written as AX square plus ay square plus az square root under. And unit vector can be written as vector by mod. So vector is axi plus ayj plus azk divided by ax square plus ay square plus az square. So now we can write any vector in 3 dimension. हम लोग किसी भी वेक्टर को लिख सकते हैं वेक्टर a is axi plus ayj plus azk. तो आप किसी भी वेक्टर को अब आप लिख सकते हैं a can be written as axi plus ayj plus azk. तो a general vector A can be written as mod and unit. So unit vector in the direction of A is vector by mod. Vector A can be written as axi plus ayj plus azk. X, y and z are x, y and z component. X component, y component and z component. Mod of A can be written as x square plus ay square plus az square root under. And unit vector in the direction of vector A can be written as axi plus ayj plus azk divided by x square plus ay square plus az square root under. For example, write a unit vector. Write the unit vector in the direction of A 3i plus 4j plus 12k. So your vector is 3i plus 4j plus 12k. और आपको यहाँ इसका यूनिट वेक्टर लिखना है. A is 3i plus 4j plus 12k. मान लीजिए पहला वेक्टर है, यूनिट वेक्टर लिखना है. तो यूनिट वेक्टर को कैसे लिखते हैं? वेक्टर बाई मॉड. व्हाट इज वेक्टर? इट इज 3i plus 4j plus 12k. And what is a mod? 3 square plus 4 square plus 12 square, and it is 3i plus 4j plus 12k divided by 9 plus 16 plus 144. So unit vector in the direction of vector A is vector by mod, that is 3i plus 4j plus 12k divided by 13. In the similar fashion, if the vector B is I plus j plus k, and write a unit vector in the direction of I plus j plus k. So unit vector is vector B by mod B. So unit vector in the direction of B is I plus j plus k divided by 1 square plus 1 square. So it is I plus j plus k divided by root 3. So now we can write the magnitude and unit vector in the direction of any vector. For example, if the vector A is I plus j, the mod of the vector is 1 square plus 1 square, that is root 2, and unit vector is, say, vector by mod. So it is I plus j by root 2. If a vector B is minus I minus j, then mod of the vector is 1 square minus 1 square root 2, and unit vector is B by mod B, that is minus I minus j by root 2. So we can write now the unit vector and the magnitude of vector. So magnitude of unit vector and the direction of unit vector now can be written. So now we are going to add two vectors. How two vectors are added? So we are going to discuss the addition of two vectors or subtraction of two vectors. So before that, if this is a vector A, this is also vector A, as long as the length of the vector is same and the sense of arrow is also same. So a vector is invariant under translation. A vector is invariant under translation. Vector will not vary if translated. If this is A, this is also A. If this is A, this is also A, as long as they are parallel to each other and their length is also same. And this is vector minus A. Now if this is vector A and this is vector B, to calculate the angle between A and B, A is extended, इसको बढ़ा दिया जाता है, and of course B is extended in the backward direction. A को आगे और B को पीछे हमने बढ़ा दिया, and this is the angle between A and B. This is the angle between A and B. Now this is your B, this is your A, this is your minus B, and this is your minus A. So if the angle between A and B is theta, angle between A and minus B is 180 minus theta. And angle between B and minus A, again 180 minus theta. And angle between minus A and minus B is theta. Again, this is your A and this is your B. Angle between A and B is theta. This is minus B, this is minus A, So the angle between A and B is theta. Angle between minus A and minus B is also theta. Angle between A and minus B 180 minus theta. Angle between B and minus A is 180 minus theta. So now the angle between two vectors can be of course obtained. Now if two vectors A and B and the angle between A and B is say theta, angle between A and B is theta, two vectors A and B are given and the angle between A and B is theta. If the angle between A and B is theta, to add A and B, we will place the tail of B at the tip of A at angle theta, where theta is the angle between the vector A and B. अगर वेक्टर A और B के बीच का एंगल थीटा है तो हम ये वेक्टर आपका A है, A के टिप पर, और ये अगर वेक्टर B है तो सबसे पहले हम लोग A और B के बीच का एंगल निकालते हैं. We just calculate the angle between A and B. This is A and this is B. Now we place B at the tip of A. At the tip of A, the tail of B is placed at the same angle theta. A के टिप पर B के टेल को रख देते हैं थीटा एंगल पे और फिर इसको मिला देते हैं. Now we get a triangle. Now we get a triangle. So now OP is a vector, PQ is another vector, and OQ is the third vector. So OP plus PQ is equal to OQ. So OP plus PQ is equal to OQ minus QO. OQ is minus QO. So it is OP plus PQ plus QO is 0. That means if three vectors are represented by the three consecutive sides of a triangle, then their vector sum is 0. If three vectors are represented by three consecutive sides of a triangle, then their vector sum is 0. If two vectors are represented by two adjacent sides of a triangle, then the third side in opposite direction will give you the resultant of the two vector. Then it will give the resultant of the two vector. It can also be written as the parallelogram law of vector addition. It can also be written as parallelogram law of vector addition. According to parallelogram law of vector addition, if two vectors are represented by two adjacent sides of a parallelogram, then the diagonal of the parallelogram will give you the resultant of the two vector. Resultant of the two vector. For example, if vector P and vector Q this is P and this is Q, and the angle between P and Q is theta. This is D, O, A, B, C and D. If two two vectors P and Q are represented by two adjacent sides of a parallelogram, then the diagonal of the parallelogram will represent the resultant of the two vectors. Vector P and vector Q are two vectors represented by two adjacent sides of a parallelogram. Then the diagonal of the parallelogram will give the resultant of the two vectors. So R is the resultant of vector P and Q, both in magnitude and direction. The magnitude is represented by the length of OB, and direction is represented by the angle alpha, which the resultant makes an angle, alpha angle with P. So now OB whole square can be written as OD whole square from Pythagoras theorem to DB whole square. OD is OA plus AD whole square plus BD whole square. So OB square is OA square plus AD square plus 2OA AD plus BD whole square. A square, B square, twice AB. Now, from this triangle, cos theta is AD by Q and sin theta is BD by Q. Now AD square plus BD square, OB square is OA square plus AD square BD square is AB square plus 2OA into AD. OA is R square, OA is P square, AB is Q square plus 2, OA is P and AD is Q cos theta. Again, tan alpha is BD divided by OA plus AD, and BD is Q sin theta and OA is P plus Q cos theta. So we have written that the resultant of two vector P and Q, this is vector P and this is vector Q, and the angle between P and Q, this is also Q, this is also P. Then we have written that the resultant of P and Q is R, and this is OA, D, B and C, and we have proved that the resultant R square is P square Q square plus 2PQ cos theta, and resultant makes an angle alpha. Tan alpha is Q sin theta P plus Q cos theta. This is theta. So cos theta is AD by Q and sin theta is BD by Q. So the resultant of two vector P and Q at an angle theta has been written as R is equal to P square Q square 2PQ cos theta, and the angle, the resultant makes an angle alpha with P, and P is given by tan alpha is equal to Q sin theta plus P plus Q cos theta. For example, if theta is 0, theta between P and Q is 0, theta between P and Q is 0. So R square is P square plus Q square plus 2PQ cos 0, and cos 0 is 1. So it is P square plus Q square plus 2PQ, that is P plus Q whole square, and R is R max, that is P plus Q. So the maximum value of resultant is when the angle between two vectors is 0 degree, and here theta is 0, so sin 0 is 0, alpha is also 0. Alpha means this is P and this is Q, so this is your R. R makes an angle alpha with P and Q. Again, if theta is pi 180, तो cos 180 का वैल्यू -1 होता है, cos 180 is -1. So again R square is P square Q square 2PQ cos pi, and cos pi is -1, so R square is P square Q square minus 2PQ, that is P minus Q whole square. This is R, and R minimum is P minus Q. If the resultant is minimum, if the angle between P and Q is 180, and sin 180 is also 0, so alpha is 0. So this is your P, this is your Q, and this is your R. The angle between R and P is again alpha is 0. Now if theta is 90 degree, then R square is P square plus Q square plus 2PQ cos 90, and you know cos 90 is 0, so R square is P square plus Q square, and R is P square plus Q square root under, and tan alpha is sin 90 is 1, Q cos 90 is 0, Q by P. And geometrically it can be written as, if this is P and if this is Q, this is your R. R is P square plus Q square root under, and alpha is, say, tan alpha is Q by P. So of course today we have discussed the addition and subtraction of vector, and also how the vector is represented. So in the next lecture we will discuss further the addition and subtraction of the vector, कि वेक्टर को आगे हम लोग कैसे जोड़ेंगे और घटाएंगे, इसकी बात होगी. फिलहाल आज यहीं तक. थैंक यू.